In this video, we'll explore how to optimize MLOps pipelines using effective caching strategies. By mastering these techniques, you'll enhance your skills in reducing computational load and accelerating model deployment processes.
Imagine cutting your model deployment time by half. Welcome to the world of caching in MLOps. In this video, you'll learn how caching can significantly reduce computational load and speed up model deployment processes. This is the first step in optimizing your MLOps pipelines, making them more efficient and reliable. Caching, in the context of MLOps, refers to storing intermediate data or results that can be reused without recalculating. This practice is integral to pipelines as it saves time and resources. We often implement caching at various stages, from data preprocessing to model training, to reduce redundant computations and accelerate workflow. Efficient caching mechanisms harmoniously integrate with existing systems, ensuring a smoother, faster data processing experience. The benefits of caching in model deployment are numerous. First, caching speeds up the deployment process, allowing for quicker model updates and iterations. By minimizing redundant computations, it reduces computational costs and resource usage. This efficiency boost not only improves scalability but also enhances the reliability of the deployment process, ensuring consistent performance. Ultimately, these improvements lead to greater user satisfaction as models are deployed faster and with fewer errors.
In MLOps, we primarily use three types of caching mechanisms: in-memory, disk-based, and distributed caching. In-memory caching stores data in RAM, providing lightning-fast access but limited by memory size. Disk-based caching writes data to disk, offering larger storage at the cost of slower access times. Distributed caching, often used in large-scale systems, involves multiple nodes sharing cache data, balancing speed and scalability. Choosing the right mechanism depends on your specific needs, such as speed, storage capacity, and infrastructure. Designing and implementing cache layers in your MLOps pipeline involves several steps. Start by identifying stages where caching can offer the most benefit, such as data loading or model inference. Use tools like Redis or Memcached for efficient in-memory caching. Follow best practices such as setting appropriate cache expiration times and ensuring data consistency. Avoid common pitfalls like over-caching, which can lead to stale data and increased complexity. Proper implementation enhances performance and reduces operational overhead. Troubleshooting caching issues involves identifying cache misses, which occur when the desired data isn't found in the cache. Stale data, resulting from outdated cache entries, can be another problem. Employ debugging strategies like logging cache hits and misses to analyze performance. Implementing robust monitoring solutions helps identify issues early and allows for continuous improvement. Regularly review your caching strategy to ensure it meets the evolving needs of your pipeline, adapting to changes in data and model requirements.
Let's explore a real-world example of successful caching in MLOps. A leading tech company faced challenges with long model training times and deployment delays. By implementing a multi-layer caching strategy, they reduced redundant computations and improved data access speeds. Despite initial challenges like selecting the right caching mechanism and ensuring data consistency, they applied solutions such as adaptive caching policies and robust monitoring. The results were remarkable. Model deployment times decreased by 40%, and resource utilization became more efficient, demonstrating the power of effective caching. Several tools and libraries facilitate caching in MLOps. Popular options include Redis, Memcached, and Apache Ignite. These tools offer various features, such as distributed caching, persistence, and support for different data structures. When choosing a tool, consider factors like ease of integration, scalability, and specific pipeline requirements. Some libraries, like DVC and MLOps, also offer built-in caching capabilities, simplifying the process for developers. Explore these options to find the best fit for your MLOps needs.
The future of MLOps caching is shaped by emerging technologies and trends. AI-driven caching solutions are becoming more prevalent, enabling intelligent cache management and optimization. Edge computing, which brings computation closer to data sources, is impacting caching strategies by reducing latency and improving performance. As automation continues to rise, caching processes become more streamlined and efficient. Additionally, sustainability considerations are driving the development of energy-efficient caching solutions, aligning with global efforts to reduce carbon footprints. In conclusion, caching is a powerful tool in optimizing MLOps pipelines. By reducing computational load and speeding up deployments, it enhances the efficiency and reliability of your workflows. We encourage you to apply these strategies in your own projects and experience the benefits firsthand. We'd love to hear about your caching experiences or any questions you have in the comments below. Don't forget to subscribe for more insights on optimizing MLOps and beyond. Thank you for watching.